everybody, it's Ms. Smith. So today we're going to talk about polyatomic ions. I know we talked about monatomic ions before. Monatomic means one atom, mono means one, atomic means atom. So now we're dealing with polyatomic ions. So that's many atoms. Poly means many. Now, this you should have used yesterday. You should have highlighted these yesterday. If you notice, there's this chart up here, and this is called Table of Polyatomic Ions. Now you can use this is fine, but this is not a complete list. Some of the ones that you're going to see, that you're going to use, may not necessarily be on this list. So that's what this list for here is here on the back. These are all polyatomic ions. I know this is backwards, but it's okay. So these two lists are actually the same. They're exactly the same. There's not, not every single one of these are different. So this side is organized by alphabetical by name, and this side is alphabetized by formula. So it's the same list, just organized twice. Now, this list itself, you will always be allowed to use. You need to make sure that you understand this, okay? That you use this. You will always be allowed to use this on an exam. Whenever, you're always allowed to use it. This is how you are going to pass this unit. Okay, so I'm going to go into my notebook today. We're going to talk about, we're going to talk about polyatomic ions. We're also going to talk about how to put formulas together. Once you take the ions and you put them together, what you do with them after that. Some with matching charges, equal but opposite, and then other ones that are not matching. And so we're going to put them together. Now, most of the time, these are going to be anions. Most are negative charge. Let's see, most have negative charge. And then few are positive. Okay. So I'm going to give you a couple of examples. And for example, let me look here at these practice questions. I'm going to write down a couple of examples, and I want you to see if you can find them and name them before I do. So if you want to pause the video after I write them down, you can. Let's see, there's one of those rare positive ones. They do happen. Now, something I want you to know is that these will never have Roman numerals, ever. The only time you use a Roman numeral is if it is highlighted. Okay, so there's several examples. So if you want to pause this and answer them, you can. All right, now Cn minus from that list on the back of your periodic table, that list with two different columns on it. Cn minus is called cyanide. Cyanide ion. Now, they've got a charge, so that means that they are still technically called ion. You have to have the word ion out there. SO4 minus 2 is called sulfate ion. You have to be careful with these because SO3 minus 2 is sulfite ion. This is sulfate ion. You got to be careful. OH minus is hydroxide ion. NH4 plus 1 is ammonium ion. CrO4 minus 2 is, let me see, this one I forget. CrO4 minus 2, chromate ion. Some of these I have memorized, some of them I don't. NO3 minus 1 is nitrate ion, because NO2 minus 1 is nitrite ion, so be careful with that one. PO4 minus 3 is phosphate ion. PO4 3 minus 3 is phosphite, not phosphate, so be careful. And then C2H3O2 minus 1 is acetate ion. Now, you may see acetate written a different way. You may see it written, let's see, I forget how this written this other way. CH3COO minus 1. That is still acetate. Okay, if you count up how many carbons you have, how many hydrogens, how many oxygens, it still comes out to be C2H3O2. So it's the same thing. Okay. Now, let's move on. What happens when we start putting these together? Okay, now, I'm going to give you a couple of examples. We're going to put, now, normally what happens is you're going to put a positive ion together with a negative ion. Positive always goes first. Okay, the positive ion always goes first. So here is an example. This is how it is written. NH4 plus F minus. Okay, that's how this is written. So this is a positive ion because it has a positive charge. And this is a negative ion because it has a negative charge. So this is a cation. This is an anion. Now, when you put them together, things start to change, okay? Now, if you were to do this in terms of math, let's look at this real quick. If this is a positive 1 plus a negative 1, that would be 0, okay? Basic math, you know this, okay? The same kind of thing happens here. So when we put these together, because this is plus 1, and this is minus 1, they cancel each other out. So when you write this, it becomes NH4F. The plus and minus goes away, it drops off, okay? Now, I am going to say this as a general rule. Compounds never have charges. Now, for our purposes, for what I'm going to be teaching you and the questions that we're going to be doing, compounds never have charges. Now, is there some kind of ridiculous scenario where a compound does have a charge? Of course there is. Okay, so I'm not going to say this is absolute. But for our purposes, what we are doing in my classroom and the problems that I'm going to give you, compounds should never, ever have a charge. So if you put something together and you left a plus or minus up there, you're wrong. Okay, simple as that. I get that every single year. Somebody does it every single year. I don't know why. But if you put something together and you put two ions together and you still have a charge somewhere, you're incorrect. You need to try again. Okay, so let's try another one of these. Let's try a couple actually. So it's Sr plus 2, CO3 minus 2. And I'm going to scoot these over so we can write them next to each other. So we said Sr plus 2 plus CO3 minus 2. That, okay, you see these are equal but opposite charges. Equal but opposite charges. Equal but opposite charges. Cancel. Okay, so the answer for this is going to be SrCO3, and that's it. Equal but opposite charges cancel. They completely go away. So let's do another one. Ni plus 2 plus CrO4 minus 2. Now, we will eventually get to the point where we will name these. You put this together and you'll name them. We're not there yet. Right now, we're taking small steps, and we are just putting things together to see how they combine. That's all we're doing. Okay, so these are equal but opposite. I have a plus 2 and a minus 2. So this is going to be NiCrO4. Okay, so here is a couple more. I'm going to give you a couple more. I want you to try them out. So after I write them down, I want you to pause the video and I want you to try them. And then I will work them. You can, once you work them out, after you've tried it, I want you to unpause the video to check yourself. Okay, let me give you 2 more. And 1 more to the list. Okay, so go ahead and pause this video. I want you to see if you can figure them out. All right. So this one has equal but opposite charges. Equal but opposite, +2 and -2. So these go together. CdSO4. Now, something I want to point out to you. This oxygen, that O right there, is a capital O. It's a capital O here. If you put capital S with a little o, that's something else, okay? Oxygen has to be capitalized. Capitalization matters here, okay? All right, moving on to the next one. Those are equal but opposite, +1 and -1, so it becomes LiCN. The next one, equal but opposite, so they cancel, so COP. Now this is a lowercase o, this one here. Had I put a capital O there, then that would have been carbon oxygen. But since that's a lowercase o, that's cobalt. Okay, so you've got to be careful. All right, now we've done it when they have equal but opposite charges. What happens when the charges are not equal but opposite? All right, now this one, let me give you an example. Here is an example. Na +1, S -2. All right, what you do is before when they were equal but opposite, they just canceled. But now they don't cancel, so you need to do something with them. Now, again, a plus or minus you will never ever see in a compound. I didn't say anything about the numbers. Okay, when they're equal but opposite, the numbers just cancel. You don't even write the numbers down. But this time, these numbers don't cancel. I've got a +1 and a -2, so the numbers don't cancel this time. But the plus and minus are never written in a compound. Okay, so let's try this. What we're going to do is we're going to take this +1 and put it down here. And we're going to take this -2 and put it down here. Now, when I do this, the actual plus symbol disappears. The negative symbol disappears. So what I'm left with is Na2S. Okay, notice in my answer, there's no plus or minus at all. All I did was move the numbers. Okay, so I want to show you something real quick. I'm going to come back to my camera. Okay, so had you been in my classroom, I would make you do this. And I'm going to make you do it now because it looks ridiculous, but you'll remember, okay? What you do is you take the charges at the top and you cross and go down like this, okay? When you are putting ions together that do not have equal but opposite charges, do it with me. You take the charges at the top and you cross and go down. Don't go like this and just go down. Don't do that, okay? You take the charges at the top and you cross and go down, okay? One more time. Take the charges at the top and you cross and go down. Okay, you will remember that because I made you do that. All right, let's go back to this. A couple of more examples. We're almost done for today. Let's get into one that's a little nuts here. Ti 4+ and O -2. Okay. Now, this particular scenario doesn't happen that often, but I need you to know what to do when it does, okay? If you notice, this and this are factors of one another, okay? So that means that this answer can be simplified. So you can simplify before you do the answer, or you can simplify after you do the answer. That's either way. But it's just got to be simplified. So I will tell you this, a hint. I'm going to write this in. If you see plus 4, you probably need to simplify. I think I spelled that wrong. Okay. Anyway, good enough for me. Now, normally it is with a plus 4. This one is a plus 4. The only other time I've seen this is if it was like a plus 6 or something, and the anion you were putting on it was a minus 3. That would be the only other time that you have to simplify. But again, like a plus 6 is kind of rare. I'm not even sure if we've got one on the periodic table with a plus 6. Oh, uranium plus 6. Yeah, but, I'm never going to give you a compound of uranium in it anyway, so, it doesn't really matter. But if you see a plus 4, you need to check to see if you need to simplify. Now, to know if you need to simplify or not, if this is plus 4, this will be a 2. Okay? Now, I'm going to simplify ahead of time before I do my answers. So I'm going to divide both of them by 2, so this will become 2 plus. Divide this by 2, that'll become minus 1. Now I am ready to cross and go down. Now ones, like we did up here, I forgot to mention this, you never write ones. It kind of looks ridiculous, okay? You don't ever write ones under any circumstances. It kind of looks like you're a little crazy. So don't do it, okay? Don't write the ones down. The ones are understood to be there. If your symbol is there, there's your 1. That's the accounting for the 1, okay? So we're going to cross and go down. So your answer is Ti2O. That's it. Okay, now one more super difficult case that everybody struggles with is what happens when you use a polyatomic ion. Right now, this was a monatomic ion, this was a monatomic ion, this was monatomic, this was monatomic. What happens if I use polyatomic? Okay, here is a giant rule that I need you to write down, and I'm going to write it real nice and big. If you have a polyatomic ion, and you got to have both of these, and the charge, not the charge it has, but the charge going onto it is greater than 1, you need parentheses. So I'm not going to spell parentheses because I'm going to spell it wrong. You need parentheses, okay? So if you have a polyatomic ion and the charge going on it is greater than 1, you must have parentheses. Okay, so let's get into what I'm talking about. Ca plus 2 and NO3 minus 1. Okay, I have a polyatomic. Here it is. Okay, let's check to see if we need parentheses. So both things that I need, it's got to be polyatomic, and the charge going on it, not the one it has, the one that's going to go on it, is greater than 1. I need parentheses. So I have polyatomic. Here's the charge that's going to cross and go down. That charge is greater than 1. I have to have parentheses. So the answer, so I'm going to cross and go down like this, the answer is Ca parentheses NO3 2. That's what I mean by parentheses, okay? Because it's all about, are you using polyatomic and the charge going on it is greater than 1. The only time you need parentheses is when it is polyatomic. Okay, so let me give you one that's a little funky. Okay, let's say that you have something like this. Okay, we're back to what we were doing earlier. These are equal but opposite charges, so your answer is LiOH. Okay, but let's say that you were doing something like Ca plus 2 and OH minus. This is polyatomic. No matter what, polyatomic just means more than one element. well, that's oxygen and hydrogen. That's more than one element. That's polyatomic. Even though it doesn't look like it is, it is. It's polyatomic. So this is polyatomic, and this is greater than 1. So your answer for this one will be Ca parentheses OH close parentheses 2. That's the answer for that. This is the one that trips everybody up, is because they think OH is not polyatomic. They think that it's monatomic. Got to be careful. Okay, let me give you another one that's a little crazy, and then I'll give you a couple of examples to work. Ni plus 2, PO4 minus 3. Okay, still going to cross and go down. These two are not factors of each other. This is not a factor of this. I don't have to worry about that. But I've already got a 4 down here. If you've already got a number down at the bottom, leave it alone. Just like I had a 3 up here. I didn't do anything with that 3. Leave it there. Okay, the only numbers that you're going to put anywhere are the ones that are up top. So I'm going to cross and go down. And I'm going to say Ni3. Okay, this is monatomic. I mean, this is polyatomic. My charge going on it is greater than 1, so I have to have parentheses. Parentheses PO4 2. All right. So I'm going to give you a couple of examples to work, and then we will be done for today. So these I want you to try once I get all 3 of these in here. I want you to try. So after I write the third one, I want you to pause the video and see if you get the same answers that I do. Okay, so go ahead and pause this video. I want you to try these out. All right, so on this one, neither of these are polyatomic. This is monatomic, this is monatomic. So I don't have to worry about parentheses at all because neither one of them are polyatomic. Now, the charges don't match, so that means that I can't just cancel and move on. I do have to go ahead and cross and go down. So my answer is, I'm going to go ahead and cross and go down, Cu2O. That is my answer. Next, let's check to see this and this. They are factors of each other. Remember, anytime you see a plus 4, you probably need to simplify it, so you get a check. So I saw my plus 4, and then I saw minus 2. That means they are factors of each other. So this is going to become plus 2. This will become minus 1. Now I can cross and go down. So my answer is SN, open parentheses, SO4, 2. Now I use parentheses because this was polyatomic and the charge going on it was greater than 1. All right, the next one. Okay, plus 1, minus 2, cross and go down. There's a 1 going on the polyatomic, so I do not need parentheses because this is not greater than 1. No parentheses on that one. So your answer is Li2CO3. Okay, so you've got a few practice problems to do today, and then you've got a little mini quiz just to see that you know what you did today. If you have any questions, let me know.